Good afternoon, students. My name is Mr. Dominic. Today we'll be looking at the topic viscosity. What is viscosity? Viscosity is that internal property of a liquid that offers resistance to flow. It offers resistance. It prevents any material in that liquid to flow effectively. By definition, we say viscosity is the internal friction between layers of liquids or gases in motion. Viscosity is the what? Is the internal friction between layers of what? Liquid or gases in motion. Now, let me give you a live scenario of viscosity. When you get the water in a container and you get an engine oil in a container and you pour out the two substance at the same time, you pour them out at the same time, you will notice that water will run out faster than engine oil. Water will run out faster than engine oil. Now, what is the difference between the two substances that you're pouring out? The difference is the viscosity. The difference is the viscosity. We said that engine oil is more viscous than what? Than water, because water flows faster than engine oil. That is to tell you that the friction in engine oil is higher than that of water. For example, if you pick something like a coin and drop them into different two coins, you drop them simultaneously into water and engine oil, you realize that the coin that you dropped into water will get to the bottom of the container first before the one that of the engine oil. That's to tell you that engine oil creates a greater resistance to any object in motion in it than that of water. Another thing we can talk about again is kerosene and glycerin. We know that the viscosity in glycerin is more than that of kerosene. Why? Because when you try the same experiment that I just explained now, you'll notice that a coin, when you drop two coins simultaneously into a glycerin and a kerosene, that of a kerosene will go to the bottom faster than that of the glycerin. So we say the glycerin is more viscous than what? Than kerosene. Liquids that pours more faster are said to be less viscous. Liquids that pour more faster are said to be more or less viscous, while those that flow slower or pour slower are said to be more viscous. I'll take it again. Water is less viscous, engine oil is more viscous. Glycerin is less viscous, kerosene is less viscous, glycerin is more viscous. So, if I should give you a glycerin and a palm oil, from the explanation I just gave you just now, which one do you think will be more viscous? A glycerin and a hot palm oil. Let me put it that way. A glycerin and a hot palm oil. Of course, a glycerin will be more viscous than a hot palm oil. But when you carry a thick palm oil, a cold one, and you bring a cold water, which one do you think will be more viscous? Of course, the palm oil. Why? Because at that cold stage, the palm oil is very, very thick. So any substance at all in liquid form that is thick and moves slowly, we say that water is more viscous. Next, we're going to talk about terminal velocity. Terminal velocity. If you're given a container of water, let's say this is a container of water, and you drop a piece of stone into it, three forces act on the stone. I repeat it again. Three forces act on the stone. I'll list them. Number one, the upthrust. That is one of the force. Number two, the weight of the stone. And number three, the viscous force. The upthrust, the weight of the stone, and the viscous force. Now, how does the weight of the stone act? Weight always acts how? Downward. And we call it what? mg, which is the weight of the stone, mass multiplied by acceleration due to gravity. Next, we talk about the upthrust. Upthrust is always a force that pushes any object sinking up. For example, the reason why a ship floats effectively on water is because the upthrust acting on that ship is equal to the weight of the ship. Once the weight of that ship overwhelms the upthrust, automatically that ship will sink. Automatically that ship will sink. So any object immersed in water, for example now, if you pick a rubber and you try to submerge it like a cup, an open cup, you put your hand inside, you try to submerge it into a water, like you put the bottom of the cup in the water and try to press it down, you notice that there's a force pushing you back up. I believe we have experienced that before. That force is called an upthrust. That force is called an upthrust. It's that force that prevents that cup from what? From sinking totally into the water. So it's a force that will be acting on this stone. And another thing again is what? Is the viscosity. Viscosity too will be acting what? Upward. Let the upthrust be U, let the viscous force be what? Be V. The viscous force now is that force that will prevent that stone from falling smoothly to the surface of the water. Instead, there will be a little resistance, opposition to the movement of that stone. But at the end of the day, it will end up getting to the bottom. So when a stone is dropped into a water, three forces act on it. What are they? Number one, the viscous force. Number two, the upthrust. And number three, the what? The weight of the stone. And the weight of the stone acts downward, while the viscous force and the viscosity force act how? Upward. Now, from here, we're going to drive a formula that we call the terminal velocity. We're going to drive the formula that we call the terminal velocity. If we are to collect all these variables and equate them to 0, this is how it will look like. We'll have u plus v, we'll have mg minus u minus v is equal to 0. Why is u and v negative? Because they are acting how? Against the force of gravity. They are acting against the force of gravity. So anybody acting against the force of gravity automatically carries a negative sign. That is why this mg is a positive. It has a positive sign. Why? Because it is acting in accordance to the force of gravity. So now from here, if we make our v subject of formula, what is it going to look like? We're going to have something like v will come back to this side. So we're going to have v is equal to what? Mg minus u. Now this formula here, v is equal to mg minus u, is what we term as our terminal velocity. I'll say it again. This formula is what we term as our what? As our terminal velocity. In some cases, this mg can be given to you as w. So this formula will look like this: v is equal to w minus u. So it's either use this formula or use this formula. All of them are termed terminal velocity. Okay. The next thing we're going to look at is the what? Similarities between viscosity and friction. Similarities between viscosity and friction. What are the similarities between viscosity and friction? Number one, both forces opposes motion. Both forces opposes motion. They all act to oppose motion. The thing is, without friction of viscosity, a body will just continue moving or will just continue sinking without any opposition. But once there is viscosity, when a friction is acting on a body, it tends to bring the body to rest. So when there's viscosity, it also tends to make somebody to do what? To float. Or it makes somebody to submerge slowly. Second similarity is that both depends on the nature of the material in contact. Both depends on the nature of the material in contact. What are we trying to say here? The friction on a smooth surface is less than the friction on a rough surface. Yes. For example, now if you're walking on a smooth surface, it's very easy for you to slip and fall. So any surface that is easy for you to slip, the friction there is low. But any surface that is difficult for you to slip, the friction there is high. So it depends on the surface in contact. That determines the friction. Secondly, if it comes to the case of water, it depends if it's ordinary water or it's glycerin, engine oil, or palm oil. The nature of the liquid matters. That is why we said both depends on the nature of the material in contact. Okay, we're going to look at the differences between viscosity and friction. We've talked about the similarities, now the differences. Number one, friction. Friction does not depend on the nature of the area, surface area in contact. It does not depend on the surface area in contact. Friction does not depend on the surface area in contact, but viscosity does. Viscosity does. Because if you notice, whether you're traveling on a car, or let's say you're wearing a big shoe or a small shoe, if you're walking on a slippery surface, the probability of you falling down is very, very high. It doesn't matter whether you're wearing a big shoe or a small shoe. But when you're talking about viscosity, for example now, if I pick this cup now and try to submerge it into water using the bottom, you notice that there will be a force pushing it up. And it will be very easy for me to submerge this cup than when I bring a very big bowl and try to submerge the same bowl. If I bring a very big bowl, I can press it for the whole of the day and it will not submerge. In fact, I can even enter inside and it will float. But I cannot enter inside this cup. Once I even try to step into this cup, what will happen? The cup will do what? Will sink. That's to tell you that the surface area in contact with the liquid is important. Number two, friction depends on normal reaction. Viscosity does not. Friction depends on normal reaction. Friction depends on normal reaction, but viscosity does not. Now, when you're talking about friction, there are ways that you can do and you might not slip up and fall on the surface. But when it comes to viscosity, once you drop something into a viscous liquid, it will continue sinking. There's nothing you can do about it. So that's why we say friction depends on normal reaction, but viscosity does not. Number three. Number three, friction occurs in solid. Friction occurs in solid, while viscosity takes place in liquid or gases. So when I say fluids, I'm talking about both liquid and gases. So number four, friction does not depend on relative velocity. Friction does not depend on relative velocity between two layers. Viscosity depends on relative velocity between two layers. The thing is, the faster the object is moving, the faster it sinks. But when it comes to friction, that does not play. So those are the differences between viscosity and the differences and similarities between viscosity and friction. Okay, let's take a look at your assignment. Your assignment, you're going to do this for me. You're going to highlight the applications of viscosity. In fact, I've stated most of them. You're going to highlight the applications of viscosity. You report the assignment through the comment box. Please endeavor to do it because I consider that very, very important. You drop it on the comment box, or this is my WhatsApp number on the board 08064818759. You can submit your assignment via my WhatsApp number. I will look at it, and if there's any correction to make, or if there's anything I need to adjust, I will do that so that at least we'll be able to interact with each other. Have a nice day. Take care of yourself.